And the University of New Orleans has a friction stir welder at the NASA facility. We actually teach friction stir welding. Hey, how are you, Zach?
Doing all right.
Doing fine, thanks. And so we're doing friction stir welding out at the Michoud NASA facility in New Orleans. The rocket's going to develop 8.5 million pounds of thrust, which is bigger than the moon rocket. And the technique that's being used is friction stir welding. You take your hands, which probably today isn't a bad idea, but if you rub your hands together, it's similar to rubbing two dissimilar metals together. And as you develop friction between them, those materials under a lot of pressure develop enough heat to weld themselves together. And you don't have the traditional welding. Approaches.
Como periquitos.
By the way, there's a wind tunnel.
Dun, 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 dun.
Minutes for the lights to come on.
Dun, 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 dun.
Is again the largest in Louisiana. This here allows us to bend and flex material. The bolts that hold this down have to go into the basement. So this floor is about 3 feet thick. And there's a basement underneath here which allows this building and this big assembly to rest, and it's bolted through to the floor. And then we're able to put in large steel panels and lay it in here and push down on the panels. And we're able to determine how strong a particular steel panel would be. And then we have the ability to pull things apart. This particular machine here allows us to put welds or two materials, concrete blocks, whatever, and yank them apart to see where they fail. And that's a pretty big one. That's, again, what we have in this lab is the largest in the state of Louisiana for the lab. And in fact, here's some welds. 30. Here's some aluminum wells. And so we do some testing. Plus we have it hasn't been used in a while, but we have a welding robot. TIG welding robot. In fact, for a time there was a fiber optic piece that went with that to allow us to optically track where the weld was. So again, I have no idea whose truck that is. We have a truck. So anyway, this is one of the big labs. And of course we got little labs. We got air quality labs, we got fiber optic labs, we got power labs, we got information labs, we got computer labs, we got all that stuff. But this is the most impressive stuff, right? You don't need to see a computer on the table. You see those anyway. You're the only electrical engineer in the
Qué
crowd.
bonita. Diga hola.
Mechatronics, that's great. You guys are good. We do have a very active robotics club out here. Very active. We bring the College of Sciences and the College of Engineering, put all of our engineers together, and we do robotics competitions quite a bit. There's about 50, 75 members to that club that work on just robotics. Yes,
Bex robotics? No. What type of robotics?
our own. We start from scratch.
Yeah, I from the Bex robotics.
Yep, we start from scratch. We do host competitions out here for students in high school. So we do VEX competitions, we do FIRST robotics competitions, we do Lego League. In fact, we're doing the Southeastern United States Challenge for first Lego League robots here in February. So we'll actually do that.
Yes, Back Robotics is in retro.
We work very closely with high schools. We need to get people interested in engineering. So robotics seems to be the way to do that. So a lot of our faculty mentor high school club. We're very active in building concrete canoes. Those of you who are interested in civil engineering, we build concrete canoes. We participate in concrete canoe competitions. Usually we're in the top, not like 10 colleges participate. We usually are number 1 or number 2. A lot of awards. As you walked in, you might have noticed all those awards in the cabinet. Plus, our mechanical engineering department builds Baja racing vehicles every year. So they're given the motor, but they completely build the car around the motor. Welding the frames, putting all the wheels on, the whole bit, and then they go out and they race the cars, which is kind of cool. Every once in a while you'll hear it running around the campus. We also have some NASA propulsion equipment here. We have a small rocket motor and things like that we can play with. By the time, this is going to sound funny, I think, but you know, everybody has an undergraduate specialization, and we all think of graduate school as also being a specialization. But the truth is, engineering is getting so complicated. I mean, look at you, mechatronics, right? Which is a thing between mechanical engineering and electrical engineering, or computer engineering. We're starting to see more and more of that. Because you just don't go to Mars because you had 3 electrical engineers doing it, right? You go into Mars because you got this massive team of all kind of engineers, each contributing. And so what we like to do is get more and more of our students involved across the disciplines, because we think that makes a better engineer out of them.
Okay. We can be something
Okay, robotic clubs?
Yeah, robotic
All
club.
you got to do is be a student here and you're in the robotics club. All you got to do is say, I'd like to be in the robotics club. You got it made. You can either be in the College of Sciences or you can be in the College of Engineering. You want to be in the robotics club, you got it. In fact, we've just given one of the largest lab areas on the 7th floor where you work to the robotics club. And we've allowed them to, we bought them test equipment, we bought all kinds of stuff. Hi, Byron.
I'm not here, I'm invisible.
Is this
I'm
your
just in
truck?
time. It can be.
It can be. Byron is our technician for civil engineering. So you know when I was telling you about ripping things apart, this is a group of students considering UNL for graduate studies. There's a fair amount of civil engineering. They're all from Mexico, Sonora, Durango, Veracruz. I tried to say it right.
So,
I'm sure I murdered
what would you, so what y'all feel on now for graduate? Environmental or more structural side?
Well, we got one electrical engineer who could care less about.
He just wanted.
He's one of my kind.
So,
The only friendly face in the group.
yes indeed. So who's structural? Who's structural out of you all? Not all environmental? So
We got a
for wastewater?
We got a mechatronics. We got a mechatronics,
Okay.
Hi.
Electronics?
Mechatronics.
robotics.
Oh, robotics. Okay. A little bit of EE and mechanical.
That's it.
That's pretty cool.
Industrial.
Industrial?
I studied industrial engineering.
Okay.
It's
So you're
similar.
good in plants? Yes.
Yeah.
Okay. Yourself?
German.
Okay. And you EE. And you?
Telecommunications.
Electrical communication?
Yeah.
So you just like to
That's
talk
my,
electronics.
by the way, that's my field of expertise is telecommunications. In particular, optical communications. My thing is laser through the atmosphere of fiber optics. That's what my work has been in.
So everybody would like to come in civil, just about, for graduate?
Just the ones that can't do anything else for a living.
What you trying to say?
Just kidding, just
Bonitos y gorditos, chicos.
So, right. So I wanted you to show them your your stuff that you
We have a lot of cool stuff. We have a loading frame here. We actually have 6 actuators, but we've only been using this here one. We have 5 others. We can actually set them all up at the same time, put them all into compression, and run them simultaneously. Or we can change configurations, and we can move this here. I-beam was up above to this here location, and we can take this here actuator and turn it into its horizontal plane, and we can do a shear test. We have done a number of those tests also. Then we have a large MTS and those grips there. If I'm not mistaken, I want to say they have like a 75,000 pound capacity in pulling with those grips there. We do have another set of grips which are smaller in the cabinet over here. And we have another set of grips which is just slightly smaller than those. Yeah, so we have a cooling tower on the outside. And this is a reinforced floor, so you see where these caps are? You don't have to worry, you're not going to fall through that. But you see where these caps are? Each cap right here can hold 10 kips. So like 200,000 pounds per hole. 200,000 pounds.
또 사파티안.
So we have used, it's been some years. The last time I've used this here floor for research was with Dr. Paul Harrington. He's a mechanical professor. And I did, I done some steel panels with him. We tested welds and stuff on steel panels. I want to say it was about 16 panels we test for about a year every morning. I would come in here with him, and we would pump up the bladder. We had a bladder. We would pump it up full of water, and we had we have load cells where we'll go underneath the floor, where we go into the basement, go down, and then we would test the panels for each one, bending them. They were what 4x8, 4x12 steel, quarter-inch steel panels. So pretty good, just dangerous.
That's right.
But it wouldn't be no fun if it wasn't dangerous. As research is always dangerous, but fun. But we have a lot of equipment. We haven't been using it for a while. The last time we used this here was for naval kind of program they did. And then Dr. Cora built these here boxes here, and we did a air quality test with this here. And they have 1, 2, 3 different chambers, 4 different chambers actually. And what we did was we showed pollution inside of buildings, because that wasn't a study that was done. And so we were showing how the air movement inside the building is very slow to none, very stagnant. And so the pollution sits inside of buildings, homes, commercial buildings for longer periods of time versus being outside, because normally that's what the study is done on. Plants and stuff discharging into the atmosphere. So we wanted to do something that was inside. And it was a pretty successful program. We had I think about 60 Brazilian students came and helped on with this here project over the summer. This was actually the second time we've done it. Back to back for 2 years. Yes.
Wow.
Yeah.
All right, you guys ready?
Oh man, it's over with already. You're welcome.
Thank you.
Hey. And they're up in here working on the steel bridge. They're starting their late, but they're starting. So that's why we see the welders out. They're getting ready for competition for building the steel bridge. We haven't been to a national display with our steel bridge for 8 years.
Oh, that's a long time.
That's a very long time. For 8 years, we've been like a Uber. We suck.